Test series 1, question number 44. The question is about a fault on a bus. 4 identical generators are shown. We are given that a fault has occurred on a bus. So, what are the values which are given? Generator reactance is given as 0.2 per unit and fault MVA is given as 1500 MVA and the generator ratings are 100 MVA and 33 kV. So let us assume this as the base MVA and base kV. For convenience, we will assume the base MVA and base kVA as same as that of the generators. So we have to find out the value of the reactance X so as to limit the fault MVA to 1500 MVA. So this is a case of symmetrical fault. So we can construct the positive sequence equivalent circuit of the system. The positive sequence circuit of this system is as shown. Here you have the two generators which is having their reactance as 0.2 per unit, and between this that reactance X is connected. Again, in the other bus we have another two generators and the fault is occurring here. This is 0.2 and 0.2. So you are required to find out X so as to limit the fault current to fault MVA to 1500. So from the fault point we can find out the Thevenin's equivalent reactance. So Thevenin's equivalent reactance is these two will be in parallel having an effective of 0.1 and these two also will be in parallel having an effect of 0.1. So in effect the total per unit impedance of the whole system is 0.1 parallel, that is this 0.1 is in parallel with a series of 0.1 and X. So this is the total per unit impedance of the whole system. So we have fault MVA can be defined as base MVA divided by per unit reactance. So 1500 is equal to 100 divided by 0.1 parallel 0.1 plus X, that is 100 into 0.2 plus X divided by 0.1 into 0.1 plus X, that is 1.5 into 0.1 plus X equal to 0.2 plus X, which implies X equal to 0.1 per unit. So the value of the reactance that should be connected to limit the fault MVA to 1500 MVA is X equal to 0.1 per unit. The correct option is option B.